What I'm going to do in this session is essentially just not quite pick up where Morton left off, but go back over some of the things that Morton briefly mentioned and sort of fill in some dots, do some hopefully successful demonstrations, and generally we'll play with some stuff, have some fun, and keep our fingers crossed that everything works. So I guess this next intersection is a nod of the head to the next generation of Star Trek. Where are we going to go next? But before we do that, I wanted to take a look at some of the things that we've already done that you may have missed, or some little features of things that we've recently made available that it's worth just touching on at this point. So we're going to see some stuff that's very ready. You've got it. It's in your conference edition packs, and it's in the versions of APL that you currently have. We're going to look at some stuff that's pretty nearly ready, stuff that's going to be in version 13.1. We're going to look at some stuff which will be ready some point after that, maybe 14, maybe during the year, and maybe later. And then we're just going to look at some stuff which the word ready doesn't really convince us at all. There's going to be some smoke. There's not going to be so much smoke that you can't see what's going on. And there's going to be mirrors. Hopefully there won't be so many mirrors that you can see what's going on. I'm trying to pitch the smoke and mirrors just to hide enough, just to illuminate just enough. And of course, if things do go horribly wrong, there's going to be a certain amount of panic happening. So the stuff that we've got that's already ready that you have, we've made with version 13.0, we introduced a new version of the IME, the keyboard input method editor. And there's a couple of features of that which are quite cool that I want to demonstrate to you. As I say, that's in 13.0. And as I say, if you haven't got 13.0, you will all have, or you should have, when you've picked up your USB sticks, you'll have a copy of the conference edition, which will include the new version of the IME. The stuff that's very nearly ready is the stuff that will be coming in 13.1, coming to a shop near you soon, nearly. As Morton said, there have been many, many bug fixes in 13.1, but at the same time, we've taken the opportunity of internally looking at some of our code and tidying it up a little bit so that, you know, in the future it's easier for us to maintain. As we get more and more developers on board, you know, it's not such a chore for a new person coming in to get to grips with the code that we already have. We've extended the support for large arrays in version 13.1 on the 64-bit systems where you can have arrays with more than 2 to the 32 elements. There were still a few niggling issues there that we have hopefully now all nailed down. But we've also extended the component file system so that you can, on the 64-bit APL, have components with a size greater than 4 gigabytes. We've also added a new system function called quadf_hist, which I believe was a function that was in some other APLs. And it's essentially a function that just returns information about the last thing that happened to a component file. For example, information about who and when a component file was created and who and when the last update was made to that file. We've also extended the autocomplete for .NET objects, which is something that a number of people have been very keen to see. This is driven partially, as I say, from customers, but also from, I think, the fact that more and more of us in the office are using things like C#, Visual Studio, and other development environments, and we very quickly realized that our autocomplete was leaps and bounds behind what those guys were doing, and clearly we could make a better job. Also, in 13.1, we've made a number of performance tweaks. One of the most obvious ones that hopefully you may all benefit from to a greater or lesser extent is we've improved the handling of blank lines and in fact, not only blank lines, but lines in functions that only contain comments. What we have in versions prior to 13.1 is slightly more overhead in processing a line that has no executable code on it. And in 13.1, we've sort of shortcut that line transitioning with a function. So if you, you know, there are measurable performance benefits there if you write a function that has a large number of comments either at the top or at the end. And I know that some of you that do source code management or have patterns in your organisation about how people should document their functions and so on, you most likely see a benefit from these speed ups. It's not huge, but every not huge performance improvement we make adds up to eventually something that is huge. And the other 13.1 feature that I want to talk about a little bit today is this thing called Quad DMX, which Morten briefly mentioned, I think, which is some extended error information. The stuff that is nearly ready, so this is stuff that's not going to be in 13.1, is the remote development environment, and we'll look at some demonstrations for that. And then we're going to look at some other stuff, that bridge that Morten mentioned before. I mentioned it in my subtitle, A Ride Over a Bridge. Oh, a bridge too far, I thought might have been a good one, but I wasn't confident enough to write that one down. And I've introduced this new snappy little acronym here. YVOVTKDB is the pronunciation that you'll find on Wikipedia. And what it stands is for yet another way of viewing the CDD database. And we'll see that as we hit one of the demonstrations. So the stuff that's already ready is the IME. One of the main features that we added to it, in addition to just generally making it easier to set up and more globally useful, is that it now supports overstrikes. So if you're struggling to find that particular APL character on your keyboard, but you know what it's composed of, you've got a reasonable chance of now being able to generate that with an overstrike sequence. And I'll demonstrate how that works. What we plan to do as well at some point, if we haven't already done that, is make the IME available on the website just as a separate download, because of course it's an input method editor that will work on any compatible Windows application, not just APL, but you can use it to write into Word or PowerPoint or a whole host of Windows applications. We'll go through the Quad DMX, which is DMX for Extended Diagnostic Message. It provides more information about errors than you would currently see from Quad DM and Quad EN. It's designed to be thread safe. One of the issues that we have with Quad EN and Quad DM is in a multi-threaded application, those variables are in fact not thread safe. So if you're handling a trap in one thread and another thread is running an errors, you could potentially see an overlap of the use of Quad EN. Although, to my knowledge, no one has ever actually fallen into this very small timing event where that could actually happen. But Quad DMX is guaranteed to be thread safe. And it's extendable. We can, over the years, provide more information with Quad DMX and extend those areas in the interpreter that are able to produce this extended error information. So let's take a quick look at some Quad DMX examples. I did consider typing these, but I sort of thought that we'd probably end up looking at unintentional errors as well as the errors that I was intending to show, and I would get confused and it would go horribly wrong. So what I've got is some carefully pre-prepared bad APL expressions. This is probably, perhaps the only APL demonstration you see where every line is intentionally wrong. Which is pretty much what I do all the time anyway. So here, hopefully you can see this at the back. Unfortunately, because this is a PowerPoint slide, I can't make the font any bigger so you can read it. But essentially, I've done a Quad F create on a file, and it's come back with a file name error. What Quad DMX allows us to do is to get a little bit more information about the error. There is an item called message inside the object that is returned by the system function Quad DMX. And the message for file name error is unable to create file. We can have a look at the OS error field of Quad DMX, and what this is a field that's populated by something that's come from the underlying operating system. Why has the interpreter generated this message about unable to create the file? And what we see here is a two-element vector. We see a platform-dependent number that we could use to go online and figure out what does error number, in this case, 3 mean. but we also have a character vector that the operating system has provided where it in itself tells us, hopefully in a short and snappy sentence, what error number 3 means. And in this case, on a Windows platform, error number 3 says the system cannot find the path specified. So clearly what it's telling us is that the path name of the file that I wanted to create is invalid. And in fact, you probably can't see that, but I wanted to create a file in my temporary directory, and I actually tried to create it in a directory called TNP, not TMP. So the C:/TNP directory doesn't exist. The system therefore cannot find the path, and we get this particular error. Fortunately, also on with the Windows platforms where we have the status window, when an error that has extended error information occurs, we automatically, assuming that your options are configured to do so, pop up the status window and provide. But those 3 pieces of information all in an easy-to-digest line in the status window. Where this differs from version 13.0, where, for example, if you did FQuadWC banana, you would have seen text in the status window even if you tracked the error. One of the nice changes that we've made with 13.1 is that you only see this thing pop up for errors that aren't tracked. So if you've got, for want of a better expression, intentional errors, or if you've got traps around errors in your code, you're not going to get this box popping up all the time to tell you that something's gone wrong that you already knew might have done. So as I said, QuadDMX is a system function that returns an object, and of course in Dyalog APL the autocomplete works and will give us a list of the things that are within that object, which means, well, which is sort of self-documenting, and it saves you a little bit of typing, obviously. If we look at a few more of these fields, some of these are interesting and relevant to you, some of them are perhaps more interesting to us at Dyalog. One of the fields that DMX returns is something that we call internal location, which is designed to help us more than yourselves. If you get an error back and you still, with all the information that QuadDMX has generated, can't figure out where it's come from, we have got in there a internal, it's actually a line of source code in the interpreter where we generated this error. So we can look at that and say, oh well, we've got to it from this part of the source code, and therefore that's exactly where this error is coming from. We did consider hiding this information away somewhere, maybe encrypting it a little bit or encoding it so that it wasn't so obviously a reference to somewhere in the APL source code. But in the end, we sort of decided that it was quick, it was snappy. It's internal, so you're probably not going to use it very much anyway, in which case we could use whatever format was most convenient for us. And of course, QuadDMX has got a field called DM, which basically just contains the same information that would otherwise have been in QuadDM. Okay, another field that's in QuadDMX is this thing called help URL. So after an error, we generate a field that contains an HTML address. Now, the idea is that it would be nice if you could click on this in the session. That functionality isn't there yet and may or may not make it into 13.1. But in the absence of being able to click on it, you could at least cut and paste that address and type it into a browser, and hopefully you will get some useful information giving you more details about that error that has happened. So in this case, there's that quite cryptic ID equals 99 on the end of this URL. And what that refers to is that every error that we have in the interpreter has got a sub-error number associated with it. So we have maybe 20 or 25 numbers that you might normally see returned via QuadEM. But what we're attempting to do here is separate, or at least provide a mechanism where one could distinguish between the umpteen thousand different sorts of domain error that you might get. Or, for example, there may be other things that might generate a file name error, and the error number 99 specifically is the one that's telling us that it was because we are unable to create the file. Error messages in QuadDMX are also grouped by some sort of category. So there are a host of extended error messages related to the component file system category, and there's also a GUI category, and a map file category and a primitive category and so on. Speaking of a GUI example here, for example, I've got an error message that says there was an error processing the type property, and that was because I tried to create something called from, moment of bad typing. Obviously I meant form, but the DMX message is telling me that I've got my type wrong. Or in a slightly more complicated GUI example, there was an error processing the items property, because items is supposed to be a vector of character vectors, and what I have there is a numeric element in that nested array. Here's another example when I'm using quad R, which is one of the search and replace primitives that were new in version 13.0. This is telling me that in my regular expression, the first regular expression I have in my call here has an offset 4. It has a missing right paren. And we can see here that I can see here, I don't know how far back we can go before you can't see it. I have an open paren ABC, and that open parenthesis should have been obviously terminated with a closing right paren. So what we're trying to do here is provide a programmatic way of finding out a little bit more about what's gone wrong when you type an intentionally bad bit of APL code. Well, not bad, but wrong. So Quad DMX is very nearly ready, and will be coming in version 13.1 of the interpreter, available in stores near you, unfortunately after Christmas, not in time for the Christmas rush. Imagine a look on the kids' faces if they opened their stockings Christmas morning. There was a nice packaged version of Dyalog APL 13.1. Oh man, snow on the ground, Dyalog APL. Christmas Day doesn't get better than that. So, something that's nearly ready, I'm using the word nearly here with a certain amount of artistic license. There's a version of RIDE on your conference edition stick, so it's ready in a sort of trial, pre-alpha, sort of have a go and see what you think sort of way. What we'll do over the coming months and years is obviously we'll extend the functionality, get feedback in from yourselves, and we'll make incremental releases of RIDE available as we go on. And the idea of RIDE, as I think Morten pointed out this morning, is that it will provide better cross-platform development. It can provide secure cross-platform development. And will be a good thing. So let me talk a little bit about the architecture of RIDE and how it works and where we see the benefits coming. Here is a Dyalog APL interpreter. It is within the interpreter, and also obviously within our source code, comprised of an interpreter engine and a user interface engine. Okay. And the user interface itself is divided into a couple of parts. We have a TTY, a text-based user interface that you see currently on the non-mainline versions on Linux and AIX and all the Unix platforms. And then there is a graphical user interface that we see on a number of different GUI devices, Windows, obviously, mainline versions of Unix, for example, mobile devices, and anything else that we may run the interpreter on that has a graphical front end. What we want to be able to do is to separate these two parts of the interpreter binary and also the interpreter source code. And if we separate these things, that means that in theory, we can insert things between the two parts. We could have a different process. We can have a user interface process that could talk to an interpreter process. These two processes may be running on different machines with completely different architectures. It would be great if we could get across machine boundaries so that, as Morten said, we could debug APL processes that are running anywhere that we can essentially get an IP address for. The other problem, or the other reason why RIDE is a good idea on the Windows platform is that we have an issue with some Windows security. By which I mean Bill, in his wisdom, has changed the rules a little bit going forward from Server 2003 to Vista and Windows 7. And this was particularly apparent when one is debugging an ASP.NET process. Where on Windows Vista and Windows 7, and presumably Windows 8 and everything else going forward, the IIS process, which is hosting your website, doesn't have permission to actually put any GUI up on the Windows desktop, which means that the model that we used on Windows XP, where if I had a web page that, for whatever reason, crashes, so in this example, when I press the button that enticingly says press me, if I get an error in my APL code, then because the machine doesn't have access to get to the desktop, we just get this error saying, well, that didn't work, something went wrong. On XP, what the interpreter is able to do is to pop up the session that's running this APL code, and we could look at the code, fix it, and carry on. But unfortunately, in the later versions of Windows, the interpreter doesn't have permissions to put this GUI up, so we can't do that. So all we're left with is this message that says, well, something's gone wrong. I can tell you where, but you're not going to be able to look at it. And it's this model here that is another place where the RIDE can kick in. We can have a RIDE process which does have permission to talk to the desktop, that can communicate with the ASP.NET process which doesn't have those permissions. We can link the two things together, and we can look at our APL code and figure out what's going wrong and hopefully fix it. So in a nutshell, there's no access to the desktop on the later versions of Windows. Let's just take a closer look at this communication mechanism that we are implementing between the remote development environment and the interpreter. We can connect a RIDE session to an interpreter. In theory, well, not just in theory, but in practice, we can also connect a single RIDE engine to multiple interpreters. So we could be debugging many things or monitoring many things at the same time. These different interpreters could be running on, could be made available through proxies. If there are security issues, we might want to connect RIDE to a proxy and let the proxy worry about talking to different APL interpreters. For example, so this communication block that we have, of course, is socket-based. And all we do is we send XML down a socket to an interpreter. It sends us XML back, and the RIDE IDE knows how to process that XML. This can optionally be made secure using the secure socket layer, which RIDE is aware of, and the interpreter is also aware of using the same code base that we've used to build Conga. So all the expertise that we have in Dyalog for secure sockets with Conga is built into the communication layer that we have for RIDE, which will allow us to use certificates to authenticate and encrypt connections. It will allow us to use those certificates or other username password mechanisms to determine that RIDE is who they say they are, and to determine, who is running the APL process, so that we can make sure that RIDE doesn't have the facility to arbitrarily connect to any process that's running on your machine. We will configure, this will be configurable, so you can say, well, if this RIDE says it's this person, then they can see these particular processes. And we might be able to use Windows authentication between processes on Windows boxes to make sure, for example, that any user can only see those processes that are running by the same user on the domain. I have no idea if that last sentence made sense. I really know very little about Windows authentication. So let's go back to this picture. We have RIDE connected to a number of interpreters, possibly through some proxies. These interpreters may be running on different machines, and we may decide that RIDE is going to use secure sockets right out of itself. But of course, once we get into a machine and all our connections are local, any communication we have between the proxy and the interpreters need not be secure at that point. It's only the public socket interface that will need to be tightened down. Let's look at another example here. Let's consider the case where on various machines we have interpreters being run on the accounts of various individuals, and we have a RIDE application that's being run by a guy called John. John can obviously connect to all of his processes. If he's lucky, and he's been given permission to do so, he can connect to a process that's running by a guy called Pete, but he's not allowed to see what Morton's up to. Okay? If we consider the case where Pete is running the RIDE, he has even more restricted permissions on what applications he's allowed to connect to. He's only allowed to see his own APL process. But of course, Morton, as the boss, he can see everything. He can break anyone's code. That's what he does. Okay, so the objectives of RIDE then are to separate the user interface from the interpreter. That's good for us. It means that we can, it's easier for us to distribute our code development amongst our developers. It's good for you because it means we can provide a more consistent interface across all of the platforms that we want to that we want to use. We can provide a UI on those platforms now where we don't have Win32. Hello. Right, Dan wants me to speak up. Okay, so as I say, it simplifies our development of both the interpreter and the user interface, which gives you these advantages. So what we have with RIDE at the moment is a separate RIDE application, which essentially just piggybacks onto the existing interpreter. So we haven't yet made the step of separating that rich UI that you're used to from the interpreter. The RIDE can sit in parallel to that, so it can work with existing interpreters. And we're going to use a portable toolkit to provide this consistent interface. And as Morten said earlier, we've currently decided to go along a Silverlight route. But given the socket and the XML-based interface that we talked about, there's no reason why we couldn't, in addition or even instead of, develop a front end in something other than Silverlight. RIDE availability, there is currently, as I say, a version available on your conference stick. Bob?
Will I be able to write a UI in APL so I can drive another interpreter from...
Yes, and in fact, when we see the demonstration, I'll show you the first step in that chain. Okay, and the stuff that's not even nearly ready is that bridge, this bridge 2.0 thing. We'll bravely have a look at a demonstration of how a bridge 2.0 might actually look and work. And the idea with bridge 2.0 is to take what we've learned from our .NET bridge and open it up, connect to other frameworks, other languages. And the idea is that the way you talk to something like Mono or Ruby or Java from an APL point of view is syntactically as close as we can make it as to how you talk to the .NET interface at the moment. It would be nice if you could have an APL workspace that was speaking to .NET from one namespace and maybe to Ruby or Java from another namespace. Let's see if we can have these multiple bridges all available at the same time. You could pass a Ruby object around, do something with it, and pass some results to something in .NET, say. So there's any number of things that you might want to bridge to. Java seems like it might be a good place to start. Certainly it's much more cross-platform than .NET and Mono. Mono is available to a greater or lesser extent on a number of the Linux platforms. Java is very widely used, of course. It's, we remember seeing Morten's graphs earlier. Was it on more than 3/4 of the browsers, and I guess therefore more than 3/4 of the machines that are running those browsers. Lots of examples of knowledge online, of course. But the idea is really that what we want to do is open the interface up to the bridge library. So in theory, you could write your own bridges to anything that you fancied. And of course, we may ship some sample bridge code with a future version of the interpreter to give you an indication about how you could do that. So now we're going to see some demos. I'm going to demonstrate to a greater or lesser extent each of these three things. And then after the demonstrations, we'll have, there'll be time for questions. And at that point, if there's any of you have questions for Morten, following on from what he discussed before coffee, then Morten will happily take questions as well. At this point, life is going to get ever so slightly interesting. The IME stuff will be fine. That works. That's ready. You've got that. That's going to work. The other things, we'll see what happens. But it's leading edge. The envelope is being pushed here. There may be some of that happening. So that's the PowerPoint done. Now I have to type. Right, now I've taken a hit on my screen resolution since I prepared this presentation, so things aren't going to be as nice and neat as they were at 4 o'clock this morning when I was working on it. So the IME, let's start a version 13 interpreter, if I can find one. There's one. Okay. Now, I guess many of you are using versions of Dyalog APL that use an IME, and what we typically see is down at the bottom here, we have a little pop-up that lists our keyboard layouts, and we have in this case, I have the GB IME layout configured, which means that the default installation that we put in is a control keyboard, so Control I gives me iota. I can probably increase the font size at this point. Okay, Control I, Control R, for example, gives me row, and so on. Control Shift P gives me the power function, and so on. But one of the functions that this IME has that probably no one knows about in this room other than those that work for Dyalog, because I don't know how well we documented it, is the support for overstrikes. Now, out of the box, if one wants to type overstrikes, one needs to first of all use the key sequence that is defined as being the overstrike introducer key sequence, which in the default configuration is Control Backspace. So if I hit Control Backspace, I'm now in overstrike mode. At the moment, there is no indication that that is the case. But if I type now colon, okay, what I see now is my colon with a little red squiggle underneath it, indicating that you're halfway through creating this overstrike combination. And if I now hit Control L, then my colon turns into domino. Okay, if I do that again, Control Backspace, colon, and I type a sequence or a character that doesn't contribute to that overstrike, like for example, comma, then I get my colon and my comma as two separate entities. Okay? And this means, again, it's one of those options. If you are maybe writing in something other than a Dyalog APL, where you haven't got the language bar, and you can't remember where domino is or any of these characters that are typically comprised of overstrikes, then if you could remember what it looks like, oh, that's probably a colon and a quad, then if you can remember where those two are, you're up and running. There are, however, options for the overstrike mode of the IME, and we can configure those options in a couple of ways. When you're inside Dyalog APL, you can go to the Unicode Input tab on the Configure box. So if we go to Options, Configure, Unicode Input, this is the box that allows us to specify what keyboard layout we want to use when the interpreter starts. So this says I want to use the Dyalog APL GB keyboard layout. If I go to Configure Layout here, then this is a box that the IME itself is presenting. And you probably can't make this out, but there are two checkboxes at the bottom. Well, in fact, there's three. The first one is checked, which says Enable Overstrikes. The next one says Overstrikes do not require the OS introducer key, which is also tagged as being experimental, because there's a number of issues with that which make it slightly awkward. But it's there so that you can play with it. And the next one is interesting. It says Use Overstrike Popper. I'm going to check that button now and hit OK here. What this tells me now is that changes to the settings like this might only apply to any applications if you close that application and come back in again. One of the exceptions is Dyalog APL, which knows how to communicate with the IME and tell it to change its settings immediately. So having done this, okay, now if I type colon, hold on, did I not do that? Oh, I still need it. Right, okay, so now, thank you. If I do Control Backspace and now type colon, what I get is a drop-down that gives me all of those APL keys, all of those APL characters that can be composed from colon. And I can use the up and down arrows to select that one that I want. A better example, I don't know. Yeah, quad's probably good. Quad, for example, can be completed by a number of different things, and we can select which one we want. And as soon as I type the next character, for example, dot, then it auto-completes with the selected character from the drop-down. The third option that we have in the configure box says that the Overstrikes do not require the OS introducer key. And if I just check that guy, now if I type colon, then I get my pop-up box straight, my pop-up list straight away without the need for explicitly entering overstrike mode. So again, I can go to the quad and just complete that way. The reason why this is marked as experimental is that it can be considered quite irritating. But more importantly, if I type hello and then type the closing quote, that quote is an element of the potential overstrikes. And the enter key at this point is going to select the overstrike that's currently in the list. So I need to then hit enter twice. If I type hello quote, I need 2 enters to do what I expect. And for little irritating reasons like that, we've sort of marked it as experimental, as an indication that we know it's not quite right, but it's something that you might prefer. Again, especially as a beginner, it may be considered to be very useful. Phil?
At one time, the overstrikes by switching to replace mode. That's still there.
Not in the Unicode interpreter. That's still there in a classic interpreter. The reason why that's not in the IME, and we'll come to this now, if I just go to Unicode import configure layout and switch that OS key thing off, because it's slightly annoying. The reason why that doesn't work with the IME is because that that insert replace mode was a mode within the interpreter, not within the IME. The nice thing about the IME is that we can use it in other applications, for example, Notepad, which itself doesn't necessarily have that concept, or at least it has that concept, but it's not something that it can communicate to the IME. Okay, yeah?
I was just curious how many of the overstrikes are supported, because if you go back historically
Yeah.
to IBM's original implementation, there were actually some quite bizarre overstrikes that were supported. I'm curious whether, number one, you have those for historical reasons, number two, whether you have a definitive list of the overstrikes that are supported.
That's a good question, because it was a question that I was actually going to address anyway. We generally only support those overstrikes that Dyalog APL knows about. Okay, because at the moment, because at the moment of how it works. However, there is no reason why we couldn't either extend that list, okay, or what is slightly preferable is actually allow in the layout table that configures how the IME works, allow you to specify your own overstrike combination. So we could provide a text file that contained the ones that we knew about and cared about, but it would be trivial for you to extend that list and put in maybe some of the ones that were of more historical interest. Or, of course, say that any Unicode code point is generated by a composition of these 2 characters. Okay? So anyway, so just with Notepad, if I type my overstrike sequence, control backspace and colon, then again here we get the pop-up menu. So the IME works across applications. It works in browsers, it will work in Outlook, it will work in Word, it will work in PowerPoint. I used it when I was working on some of the PowerPoint. It even works in, if you want to rename a file, for example, you right-click on a file name, say rename, that single line edit field there will honour the overstrikes if you have that keyboard selected. So if you want to call a file, domino transpose, then it's easy to do so. Just don't send it to your phone is probably the best thing I could say. Okay, so anyway, so that's the IME. Oh, one final point on the IME is if I want to configure the settings for the IME from an application other than Dyalog APL, I can do that, but I need to go to the control panel, region and language settings. And after you've navigated through a few layers, you see a properties box here, which pops up the same box that we use from Dyalog APL. But every time we use this box, we're changing a global setting, which is going to affect all processes that are subsequently started on the machine that want to use the IME. Okay. Is that the time already? Crikey. We haven't even got to the stuff that isn't going to work yet. Marco. Sorry? Right, yes. Okay, I'll briefly talk about that. One of the problems that a number of people have had is that they want to install the system on, they want to install Dyalog APL on systems where they either are unable to because of permission issues, or are unwilling to install the IME. And what we have introduced is an alternate mechanism of specifying the keystrokes, which now only works inside the interpreter. And what you can do is specify in your registry under keyboard shortcuts a section called chars, and this allows you to specify a Unicode code point and a keystroke sequence that generates that particular key, very much like we had back in the day with the old translate tables. But the Unicode interpreter no longer uses translate tables because it expects all its input to come externally. So this is a sort of step backwards to get away from using the IME. So the key sequence here just basically says that Unicode code point 2373, which is iota, comes from the combination of the Alt key and the I key. So if I have my interpreter running and I switch to the non-APL keyboard layout, I can now generate iota with Alt-I. But because that's the only entry I have in that table and I haven't got an APL keyboard selected, I can't type any other APL characters. But I can extend that char list to specify any Unicode code points so that I can type them in without using the IME. But that is a Dyalog APL specific section, so that's not going to allow you to type APL into anything like Notepad or Word or any of those other applications that I talked about. Right, but we really need to move on to the stuff that isn't going to work. Sorry? Well, no, because the overstrike there, no, you can't. But of course, all those characters that would be generated by the overstrikes, you can put in with whatever single keystroke you want. But yeah, again, the overstrikes is within the IME. Sorry. Right, let me show you something that's not going to work. Right, let's go to that example first. We're running Windows 7 here. And what I have here is a web page that is broken. Here I have that little rotate button example that you've seen perhaps in a number of demos that we've done. If I press this button, what I get that line that says there's been a value error. Okay, but because the APL engine that's running behind here doesn't have permissions on Windows 7 to see the desktop, it can't give me an interpreter that allows me to debug that. However, if I start up RIDE, now the nice thing about using Silverlight as a development tool for building RIDE is that it means that we have an application that can be made available through your browser. So in fact, on this machine, the way I'm configured at the moment is that my RIDE can be accessed by going to Internet Explorer and going to the appropriate link. The installation that you have for the conference edition installs a copy of RIDE locally on your machine, and in the conference edition tutorial on Wednesday, I can talk you through how that works. So if I go to my RIDE link, the Silverlight application starts up, and what we see is the RIDE front end. And again, I'm not going to be able to really do much with the font here. The layout of this is it has a list where we can specify names or IP addresses of computers, and the only entry that's in here at the moment is 127.0.0.1, which is the machine that I'm currently on, the machine that's hosting the IIS process. And then here we have a message that says there are no connections available. Make sure that the RIDE proxy is running on all the machines you want to talk to. The RIDE proxy is running on my machine at the moment. The reason there are no connections is because I need to refresh this list on the right, which I can do by pressing the refresh button. But if I refresh this, I get asked to provide a certificate file because we're currently configured in this communication to use secure sockets. So I need to tell RIDE what certificate to use so that the guy at the other end knows who I am. And I'm just going to select the John certificate. And now what we can see here is that there is an entry that says, at this IP address 127.0.0.1, there is an APL engine running, a version something.conference. It's a 32-bit Unicode version, and it's inside a process called W3WP. And if I scroll this back, we also see that we have information that's been returned to us from the certificate that it's using, so that we can see who it is, or who it is, what certificate it was configured to use when it started. So now I can highlight this row and hit the connect button down at the bottom, and we can now see that we have something that looks a little bit like a session. It's so like a session that I can type 2 + 2 and the answer 4 comes out. But now, because RIDE is connected to that ASP.NET process, if I press my button again, then rather than getting the error returned in the browser, we actually see our value error in our RIDE session. Okay, and we can see that, for example, the object here is the system.web.ui.controls button. And what I can see here, but you might not be able to make out, is the reason I've got a value error is that this says obj.text, T-E-X-T, gets the reverse of obj.txt. I've misspelt the word text in that second part. And I can fix this in the same way that I would fix this if I was using the regular interpreter. Control-Enter takes me into trace mode and pops up the script, the APL code for this website. And we can see here highlighted is the line that has failed. I can hit Shift-Enter over here, convert this trace window into an edit window. I can fix my typo and put the word E in there, fix my function. I can step through it. I can come over here and I can do a branch to quad LC. And if we go back to the browser, we can see now that my text has correctly rotated. And I've now fixed the code without having to use the underlying, the old style APL GUI. So that's, sorry?
Fix the source code or just a...
Can't fix the source code at this point, but,
Yeah.
you know, one step at a time.
Right. If you were using salt, you could easily...
If you are using salt, you could perhaps have easily fixed the... Okay. I've inserted the word perhaps in his sentence, but... Anyway, right, so let's go back to RIDE. I really thought I was going to be done in 40 minutes. I could easily do another 40 minutes. Let's go back to my RIDE, because this is where stuff sort of gets interesting. This is cross-platform. Okay, I've got an IP address in the right-hand side of my RIDE monitor that says 127.0.01, okay, which is this machine. If we all collectively cross our fingers and I, in here, type the word Ubuntu and add that to my list and hit refresh. Oh, go on, come to daddy. What this should do, oh no. Right, what I have in big letters on my notes, which I haven't looked at all yet, is I'm supposed to switch the secure sockets off when I'm talking to one of the Linux builds. So let's just switch that off and try again. Right, okay, I'm going to have to break the fourth wall now. Here is my Ubuntu machine, which has actually crashed in the APL because it tried to connect with a secure socket, which it wasn't expecting. Let me restart the APL in this Ubuntu session. Now, if I hit refresh, here now we've got 2 rows in our box. We've got this first one, which is a thing that's running in W3WP, and we've got another entry that says, on this IP address, I've got a Unix interpreter, Unix 64-bit Unicode interpreter. Okay, but again, I can connect to this, and I can type 2 + 2, and I get the answer back. And we can see, if we go back to the Ubuntu machine, that I'm communicating with this APL session that's on this other box. Okay, or if I want to be really out there, if I type the word Mac in here and add that and hit refresh, hold on, I will, oh, hold on. Bear with me a second. I'll explain what I'm doing here. I'm running on a MacBook, which is hosting 2 virtual machines. It's hosting a Windows box, and it's hosting a that Ubuntu virtual machine as well. Okay, let's just start this guy up again. Okay, so here's an APL running on the Mac, and now when we go back to, I don't know why it had got stuck, but now when we go back to RIDE, we've now got 3 rows. We've got a row that says I'm a Mac, and we've got a row that says I'm a process running on Unix, and I'm a process running on Windows. We can now connect to the one that's running on the Mac. Okay, and we can type 2 + 3 on there. Mac knows about odd numbers. Well, we can see that we're talking to this guy over here. Okay. Right. Oh, also interesting, perhaps, is I have on this machine an embryonic APL sharp engine, which if I run, it just pops up a little shell to say the APL sharp interpreter shell is waiting. If I now come back to my RIDE monitor and I refresh again, we can see it's found another MAC process. But it's found something here now which is different. It's found something where in the language column it says it's APL sharp. And we can connect to that guy. And don't die, don't die, don't die. 2 plus 2, there is also 4. Of course it is. But we can see, here's my 2 plus 2, and up here we can see what I sent to the APL sharp interpreter. So we've got this RIDE tool now that not only lets me talk across machine platforms, it lets me talk across languages now. We've got this thing which will allow me to switch between looking at stuff on a, what is this? This is a uname-a. That's the Linux Ubuntu machine. At the same time, I can switch this tab and look at something in the APL sharp engine. I can, in one place, debug and interrogate all the APL processes that are running anywhere where I can see them, essentially. Right. So that, I mean, there's all sorts of cool things about RIDE. For example, I mean, it does autocomplete. At least it does in anything other than APL sharp. If I load display into this guy, okay, oh, that's less than convincing, isn't it? Let's do it somewhere else. Let's load, no, that was on Windows. If I load display.dwas into my Ubuntu version, okay, what we're getting now, okay, it's supposed to do autocomplete for me, which is something that you wouldn't normally see in a TTY version of Dyalog APL. RIDE has got a few nice little things. It's got a little widget up here that provides a bunch of things from a Twitter feed if you've registered and said I'm interested in Twitter feeds from such and such a person. And I'm convinced that whenever I plug in an external monitor, the Twitter feed stops working because it was fine when I was at the back, not working now. Anyway, so let me close these down, because what I need to get to now, and I have not enough time to do it, is get to the really sexy stuff, which is really unlikely to work. So let me close these guys down. Okay, right. Now, so that's RIDE. Let me do something else. Right, so forget RIDE. We'll come back to RIDE in 36 seconds if I have to compress everything in. Right, let's talk a little bit about Bridge 2.0. In version 13 of Dyalog APL, we have a bridge that talks to the .NET framework. And I can do things like quad using gets system, which means that anything in the .NET framework that's name begins with system dot is available to me from the interpreter. So I can do datetime.now, and I get back something that tells me what the current time is. And this is an object, so I can do system.datetime.get, sorry, .year, I think, and it tells me that the year is 2011. Okay, that's that. In this version, which is using Bridge 2.0, I can actually type quad using gets, well, not type system, but here I can type java.util. Okay, and now the Java equivalent for a date time that we saw in the .NET is a thing called a calendar. And I can get an instance of a calendar by calling its getInstance function, which takes no arguments. But when I do that, what I get back is an instance of a Java calendar. Okay, and on this I can do things like .getTime, which returns pretty much the information as was returned by the .NET datetime object. Okay, if I load a workspace here called that, what I have in here is a workspace, is a function called calendar. Okay, which goes through that and then goes through and makes some other calls on the Java engine to get things like what day of the month is it? It's a second, it's a Monday. it's October, and so on. But there's another of other useful functions in this sample workspace. There's a thing called button, which if I press it, pops up a Java GUI that contains a button that I can click on, and I get an event in my APL to say the button has been clicked on. I can have more complicated examples. I can run this function called color, okay, which pops up a Java widget containing a color selection box that I can navigate through, and when I hit the OK, we use the Java message box class to display the message telling me what color I have used. What's good about Java, of course, is that it is cross-platform, much more so than the .NET framework. If I come back to my Java machine, sorry, my Ubuntu machine, and type APL, I can do exactly the same thing. In fact, why don't I just load what was it called? Ah, it's in there. Okay, so in this guy, calendar tells me it's the 2nd, it's Monday, it's October. Color pops up the GUI color selection box from my TTY version of the interpreter. The interpreter itself doesn't have any GUI element at all, but it can talk to Java to do all these sorts of popping up things. Let's come to that thing that was in my PowerPoint, the yet another way of viewing the CDDB database. Why don't I load something called cddb/jcddb_unicode.dewas. Okay, quite a large workspace, so it takes a moment to load. But once it's loaded, we can do Java _GUI. And what we get here now is the list of artists that are in the database. We can filter through these. I always go to Tato, don't laugh at me. But when we make the selections here, we're using the Java widgets to display the tracks that are on the album and the bitmap that is the cover of the album. And of course, on a Windows platform, we can load exactly the same workspace. Okay. And we can get exactly the same GUI. I'm very aware that I'm rushing because dinner's ready and I'm in a state of permanent hunger these days. So if we go to Toto, we go to there, and we get exactly the same UI on the Windows machine. Let's move back to my Mac. Let's start an APL session on the Mac. Let's do something slightly different here. What I said was that the RIDE can be made available over the internet, and indeed it can. If I go to my browser on my Mac, and I go to the RIDE website here, let's give it a few moments to get going. Here is now RIDE running in a browser on the Mac. I can connect. No, I can refresh, and here's that MacOS session here. I can connect to this guy. And in here, I can load /users/John D/dev/cddb/jcddb. And I can run the Java GUI from here. Hopefully. Oh, come on. Might have to poke it. Sometimes I have to poke this to... here we go. What it was doing there, it was spending a long time loading the workspace. But now we can see a couple of things. We can see now that the same workspace, I'm using a different path, but it's the same workspace. Now on my Mac, allows me to go through and show all the stuff across platform. Now we did it on Windows, we did it on Ubuntu, we're now doing it on the Mac. Nice thing about doing it here on the Mac is that I've also used this RIDE GUI front end, which we didn't have on the TTY version for the Mac. Okay, and we can see this does do things like autocomplete. Okay, it does do things like if I close this GUI down, if I do Java _GUI and I hit the trace sequence, okay, I can now trace through on the Mac connected from the write process to the APL process. I can now trace through my code that is popping up this GUI till we get to the end where we make the thing visible. And there are a couple of callbacks on here. For example, artist changed. We could do a one quad stop on that. Okay. Needs quotes. So when the artist selection is changed, we can see that there is a function here that gets called as a callback. It actually gets called twice, once with a is adjusting value of false, of true, sorry, and then one of false afterwards. And here we can see that we're interrogating the the Java GUI. We're trying then to set the data that's in the albums list with the list of albums by the particular artist that I selected, which was oh, okay, band called AOR. Okay, so we can let that run through to completion, or we can do a branch to quad LC. Oh, hold on. Okay, and we can see the content there changing and so on. So, anyway, I have to stop. But hopefully, what I have managed to illustrate is that A, I can't judge time when I'm giving a presentation with lots of stuff, but B, hopefully you can see that the combination of RIDE and potentially a Java bridge or a bridge to some other cross-platform thing allows us to address a lot of the issues that Morten brought up before coffee this morning, that you've got that cross-platform development, both in terms of how you write your APL and what you can put in your APL in terms of creating GUI and so on. And we've talked briefly about the security aspects. We've seen that we've seen all the things that Morten said, wouldn't it be nice if we could do this over a period of time? And it is true, over a period of time, we will be able to do all of those things. Thank you very much.